Use an addition or subtraction formula to simplify the equation sine 3 theta cosine theta minus cosine 3 theta sine theta equal to a half. This is in the form of the difference angle formula for the sine function. And we could match these things up. 3 theta would match up with alpha, and theta would match up with beta. So we could rewrite then sine 3 theta cosine theta minus cosine 3 theta sine theta as sine 3 theta minus theta, which would be sine 2 theta. And this is equal to, in this problem, 1/2. So we can set that equal to 1/2. Now, if we think about our special triangles, we know that for the triangle with internal angles pi over 6, pi over 3, and 90, the sides that we remember are 1, 2, and square root of 3. And looking at this triangle then, with 1 being the opposite and 2 being the hypotenuse, we would then say that the sine of pi over 6 equal to opposite over hypotenuse would be a half. So now let's look at the unit circle. Looking at the angle pi over 6 in quadrant 1, we also know that there is a corresponding angle in quadrant 2, 5 pi over 6, that has a reference angle of pi over 6, and therefore would also have a sine function value of 1/2. Now, what we have to remember is that it isn't the sine of theta that's equal to a half, it's the sine of 2 theta that is equal to a half. So what we'll need to do then is say that 2 theta is equal to pi over 6, or 2 theta is equal to 5 pi over 6. And multiplying both sides by a half in both cases, we would get that theta would be equal to pi over 12, or theta would be equal to 5 pi over 12. Now, we were to find all solutions in the interval 0 to 2 pi. So we found 2 that are within the interval 0 to 2 pi, but let's consider what if we were to start at pi over 6 and go a complete revolution around to the same terminal side. What would the angle be? It would be pi over 6 plus 2 pi. Or in other words, pi over 6 plus 12 pi over 6. So 13 pi over 6. And then if we did the same thing, find the coterminal angle for 5 pi over 6 by completing another revolution, we would have 17 pi over 6. So we can do this again. We can say that 2 theta would be equal to 13 pi over 6, or 2 theta would be equal to 17 pi over 6. Again, multiplying both sides by a half, we would get theta equal to 13 pi over 12, or theta equal to 17 pi over 12. So we have 4 angles that we have found, pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12 that would satisfy our original equation on the interval 0 to 2 pi. If we tried to do this again and go around another rotation, the resulting value for theta would be outside of that interval from 0 to 2 pi. So we have 4 solutions.